All right, everybody, thank you so much for your time today. This is Mark Nielsen from Capex Global. Welcome to our webinar, Hero's Guide to Self-Service Business Intelligence. I focus in on our sales for our East region of Capex. I work out of our Philadelphia office here in downtown Philly. So welcome, everybody. Today we're going to Dave Wenzel, our CTO, is going to walk you through our approach to self-service reporting. Some new ways of doing things, different ways than the past, some interesting ways that you can meet your business needs from a reporting standpoint. There's a lot of new technology out there, and what we'd like to do today is just kind of review a little bit of that with you, and then wrap up with kind of an offering that we have if anyone is interested, and we'll be sure to kind of follow up and contact you. So based on today's format, we won't have any time for Q&A, but we will be taking follow-up emails and calls, so please feel free to email us, and we'll be following up with each and every one of you. Again, thank you for your time, and at this point I'm going to turn it over to Dave Wenzel. Dave, take it away.
Okay, thanks, Mark. Just so everybody knows, there is a Q&A box at the bottom of your screen. You can type questions in there. If we have time at the end, I will try and go over any questions that are in there, and I will as well stay late if anybody wants to have their questions answered. Okay, so what I want to do first is give you a little bit of what I feel the problem is with self-service analytics and how we've done data in the past. So here's what we hear when we go out to engagements from our IT people, or the IT representatives. Essentially, I won't read this to you, but what we hear is that there's a lot of failed data projects out there. EDW on there stands for Enterprise Data Warehouse. It could also be a data mart or an operational data store. But these are the comments that we hear from our IT representatives. What we hear from our business users is something just a little bit different. And the theme of this is we wish we had access to more data, because if we did have access to more data, we could probably do some very interesting things. And the data that we do have access to, our business users say, unfortunately doesn't actually answer the questions that we're hoping to ask of it. So what we like to do is kind of figure out why that is. Why do we see this pattern of behavior, and what can we do to fix it? So the problem, I think, is how, as an industry, we've done data projects. So let's take a look at how we've done this in the past. So what you'll find is that when you embarked on a data project, whether it's a data warehouse project, a data mart project, or you're expanding a data mart project, is it follows this linear thinking. So what it is you start by saying, I need to gather some data from source systems, and I need to put them into an integration point, and then I need to do reporting off of that integration point. The first step that happens is, unfortunately, we start in the middle. We say, what does that data warehouse look like? And that data warehouse, what it looks like is essentially the integration point. So we go in there and we say, we want to have star schemas created in that data warehouse, and we want to have slowly changing dimension type 2 in that data warehouse, and we want to structure it a particular way such that it doesn't model any particular source system, but it's an integration point. And if you have no idea what I just said there involving slowly changing dimension type 2 and things of that nature, consider yourself very lucky. What we focus on next in traditional legacy thinking is we say, how do we get that data from the source system into that star schema or into that data warehouse? And essentially what we call that in the industry is ETL. It stands for extract, transform, and load. Those two processes, the extract, transform, and load, and the data modeling, consume the bulk of the time that we spend doing traditional data projects. What we unfortunately don't spend enough time on is the analytics piece. The analytics piece comes all the way at the end when we finally do the reports, and usually between the data warehouse and the reports is a series of abstractions to make the data faster, and we call those things data marts and cubes. But the end users only actually see the fruits of the labor at the very end of the process when the report is generated, which could be months into the actual project. And by that time, the question has changed, the business needs have changed, there's been some failure, risk of failure is high, and the process just ultimately isn't satisfactory for users. So again, to look at this, data projects have a high fail rate. Again, way too much time is spent in requirements gathering, in data modeling. Data modeling is building the star schemas and the dimensional structures, and the actual data movement of the actual data movement code going from source systems to destination systems. Throughout that entire process, a lot of the meaning in the data is lost, and that's the other problem that users see with these projects. And essentially, we want to stop doing things this way. So we have a slightly different approach to this. So what I want to cover next is our approach to solving all of these issues. What we call our approach is the Capex Agile data process. And there's a little diagram on the right that shows essentially how this works. If you're a data scientist on the call, you'll note that this is very, very close to the CRISP DM data science model. Essentially, what we focus on is we make everything an iterative process. So we start at the very top and we say, we're going to assign some resources to do the data acquisition piece. So that's the extract and the load portion of ETL, but it's not the transform portion. We're going to take that data, we're going to load it into a temporary holding area, and then we're going to give access to that data. It's going to be dirty data, it'll have duplicated data, it'll have a lot of missing data. Whatever that data looks like on the source system is what we're giving to users, because there's a lot of meaning in that dirty data, and users really want to see that. So we're going to give them an area where they can play and use that data. And we'll go over exactly how that occurs in a couple slides from now, but just as a general overview, that's the process. We're going to then allow our users to experiment with that data, evaluate that data, and see if it answers the questions they need. If it doesn't, we're going to go back and we're going to figure out why that is. Maybe we need to understand the business a little bit better. Maybe we need to incorporate additional data from other sources. Whatever it takes, that's what we're going to do. At some point in that process, the evaluation step is going to be done, and we're going to say, hey, we found some meaningful data here, and we need to incorporate this into reports or into dashboards or whatever the situation may be. And it's only at that point when we actually do the modeling. So we do the modeling late in the process. So we don't spend the initial time up front coming up with star schemas that may not actually work for the given use case. And I think that's very important. Push the modeling as far down in the process as possible. You'll notice that we never really talked about the T in ETL, in other words, the transform piece, and that's because that's essentially what the users are going to be doing when they do the data sandboxing. And we have methods we do that make this a very painless process without a lot of training and without a lot of specialty tooling, where users can go in, learn the data, and then pass that data off to the ETL developers, and then they can go and basically operationalize the process, which is at the bottom of the diagram, and then visualizations can be created, we can do data governance, and it's deployed, and we essentially repeat it. So this is the process we stress and the process we like to handle, and I'll give you some anecdotal evidence why this works in a few slides from now. But this is overall what the process looks like. So let's dig into the process a little bit more, specifically from the self-service analytics perspective. So here's the process. We start with something called a data lake, and the data lake is the raw, dirty data that I mentioned earlier, and we're going to give access to the data lake data to our users, and we're going to give them the tooling they need to actually look at that data. Now, right now, IT people look at this and they say, oh, it sounds like you're pushing data lakes in Hadoop, and we tried Hadoop a few years ago, and that experiment failed. It was very costly. That's actually not what I'm proposing. And you can use any technology for your data lake. You don't have to use Hadoop. We prefer to use Azure solutions at Capex, in which case Azure has services that allow you to do data lakes without having a Hadoop instance, but you can do data lakes on-premise as well in your data center, again, without deploying costly Hadoop hardware and hiring Hadoop talent. So anyway, we start with a data lake that has the raw data. Again, what we do is we have ETL developers that ingest any data that's needed. They do the extract and the load to the lake, but they do no transformation. Again, we want to make sure we honor the fidelity of that raw data coming in. We're going to store all of that data in its native format. We don't care what that format is. So if a system gives us JSON data, we put that in there. If it's CSV data, we put that in there. If it's any other kind of formatted data like that, even Excel files, we'll put that in there because we can process that data in the data lake natively. We don't need to do transforms to get it into a common format. Okay, so here's the actual data that our ETL developers put into the data lake. Raw data. It could be social media data from Twitter, could be line of business applications that you've developed, CRM systems, Dynamics, SAP systems, any kind of relational inventory management system, external data that you get from vendor partners. You can put that in there, or any other database. And again, we have tooling at Capex that we use, that we can train your ETL developers, that makes this process very fast and very painless. And that's the key thing, is you want this to be a low friction event so that your users have access to that raw data. If you're thinking, I'll never have a use for social media data or external data or unstructured data, you should probably think again about that. What I've noticed a trend in the industry right now is weather data. Every customer wants to ingest weather data from weather services because they can make predictions on their sales, their logistics, and everything based on weather data. And again, what we would do is ingest that weather data into the data lake and then allow our users to experiment with it and see if they can make predictive or valuable analytics based on the weather data. Again, the next step is the users. The users take over here, and this is the T piece of ETL. This is where the users, with the help of the ETL team or the help of Capex, goes in and we take a look at that data with your business users. What we're specifically looking for is to come up and answer a business question that you may have about that data. We sandbox that data, we experiment with that data, we transform that data, we scrub out the dirty data. Again, while we're trying to find meaning in why that data is dirty, we do all kinds of analysis, again, depending on what the business case is that you're looking to solve. Now, here's the thing. Everybody thinks, oh, this is going to require specialty tools and specialty skill sets that your people need. And it's just not true. We have a lot of users that use this technique, and they do their data lake experimentation using Excel. That's a perfectly valid way to do things, but we also have tools that provide a nice, easy way for users to go in graphically and tweak and tune their data as they see fit. Even Power BI works really well for this. It has a great feature that does transformation that will allow you to find meaning in raw data. Once your users have gone in there and they've done the transformations and the experimentation, what they're doing is essentially putting that in a different area of the data lake, and that portion of the data lake is the enriched data. They're never deleting any raw data or changing any raw data for that matter. They're simply enriching it into another section. And I'll go over exactly the mechanics of that in a slide or two from now. Once that data is in the enriched state, again, this is what your users are going to be working with the IT department to do. Now we can do other things with that data lake data, the enriched valuable data. And that's where, again, we apply the schema to it. At this point, we probably know what the data looks like that we need to report off of. So we don't necessarily have to create those star schemas, but we can, and a lot of places do. So we can create essentially new tables or new structures within your existing enterprise data warehouse, all without doing, standard ETL processes, because we've already done them in the data lake. Again, we could report directly off the data lake, but generally you don't want to do that because data lakes tend to be a little bit slow as far as querying goes. After the data is in your enterprise data lake, you can do reports using Power BI or Excel, but you can also apply machine learning. So I want to do predictions on the data that I have in my data lake, or I can even do real-time dashboards that I can't do in my data warehouse because maybe my data warehouse is only loaded nightly or hourly or something like that. Now let's just stop here for a second. You're probably thinking to yourself, well, you just said the data lake tends to be slow. How are you putting a real-time dashboard on data lake data that's slow? Okay. If you're thinking that, the way we do that is, again, we have sections of the data lake that are tuned for specific needs. So we have sections of the data lake that are specifically tuned that we can do real-time dashboards out of them. As fast as the data is coming in, we can make dashboards on the data coming out that's been enriched. And there's other sections of the data lake, again, that's meant for slightly less real-time data. But there's all ways to do this, and we'll kind of discuss that, how we do that in the next few slides. Okay. The one piece I missed at the bottom is a data catalog. When we go out and we do these engagements, what we hear a lot of times is that customers experimented with data lakes in the past or with this data lake concept, and it maybe didn't go as well as they thought it would, because essentially what they had is just what is pejoratively in the industry called a data swamp, and that's just where everybody has free-for-all access to the data lake. There's no structure to it at all. There's no governance to it at all. And what we do is we impose a data catalog where users can go in and say, okay, what is, I'm looking for a specific piece of data. Where can I find that in the data in the data lake? And they query the data catalog to do that. It'll also tell them things like how old the data is, the processes, who the owner of the data is, things of that nature. We'll discuss that a little bit later. So this is the general process in a nutshell. The data lake is essentially the self-service enabler that allows you to have self-service analytics. It'll solve probably 80% of the analytical needs of your users. I made up that number. I'm not sure if that's exactly accurate, but in my experience, about 80% of all problems are solved just by using a data lake and not worrying about anything else that you may want to deploy, such as that data warehouse, things of that nature. So here's a little bit more on data lakes. Let me give you an example in the real world of how a data lake can solve a problem quickly. So a few years ago, it's actually a number of years ago, I was asked to solve a problem with a pharmaceutical company. Essentially, they had a very high-priced medication that solves a very debilitating disease. It's a very expensive medication, but unfortunately, prescriptions were not getting filled. And if they're not getting filled, obviously the pharmaceutical company isn't making profit and they can't create new drugs, so forth and so on. So what they did is they brought in a series of consulting companies and said, the question we're trying to answer is, what are the 3 things we can do to ensure that prescriptions get filled and that we get paid? In each case, the consulting company came in and they proposed the legacy model, the model in the top left. So they came in and each one said this would be between a 12 and an 18-month endeavor to figure out the answer to that question. And they started with, we're going to have to ingest data from the actual pharmacies. So in other words, the pharmacies you see around your neighborhood. And then we'll have to take that, we'll have to negotiate contracts with those individual pharmacies. We'll have to figure out exactly what data we need off of their systems and exactly what format we want. And then we're going to have to put them somewhere. So we're going to have to build a data warehouse, but we're not exactly sure how the pharmaceutical model works. So we're going to have to learn your business in order to build that star schema and those slowly changing dimensions. Then we're going to have to ingest all that data and put it through an ETL pipeline, and we're going to have to hire ETL people. We're going to have to build data marts, cubes, and then finally, at the end of the day, we'll create some reports for you. Again, that's a 12 to an 18-month process. The pharmaceutical company, they said, you know, we can't wait that long. Is there any way we could do this differently? So I said, yeah, there's absolutely ways we can do this differently. I'm not sure if it'll work for you, but let's give it a try. So my idea was quite simply, let's go to the pharmacies and say, give us your data. Again, make sure you're not violating any HIPAA rules or anything like that, and give us as much of the data as you feel comfortable giving it to us, and give it to us whenever you want to give it to us in whatever form you want to give it to us. So that started the conversation. Well, do you want to see this piece of data and that piece of data? And I said, absolutely. I want to see anything you want to give to me. Well, how many times a day do you want to see it? Again, as many times is perfect. Once a day would be fine. Every hour is great. Every 2 minutes is even better. Whatever works for you. And they said, what format? CSV, Excel, JSON? How do you want to see the data? I don't care. It doesn't matter. And each pharmacy gave it to us, the data. They gave us varying data, different data, dirty data in a different format. It doesn't matter. Once we got 2 or 3 pharmacies to sign on and just give us their raw, dirtiest data, we were able to do that in essentially 2 to 3 weeks. We started getting data in, and again, we just put it into a data lake. Now, this isn't a big data problem. There's not a lot of data. There's only about 30 or 40,000 patients that are on this drug at any given point in time, so it's not like it's a big data problem, but it's a problem we need to solve quickly, so it's a fast data problem. Once that data was in the lake, now the question became, okay, do I, as the architect on the project, need to learn everything about pharmacies and what the insurance benefit pipeline looks like? Or can I leverage a user that can go in there with me and we can figure out the problem together? And that's what we did. So I looked at that dirty data sitting side by side for 3 weeks with a person who was their subject matter expert and dealt with pharmacies and insurance companies all the time. We looked at the data, we kept iterating through it. In approximately 3 weeks, we figured out the answer. And again, the problem we were trying to solve is, what are the 3 reasons why prescriptions are hung up in the pipeline and don't get filled? And we figured that out, and we even came up with creative ways to incentivize the pharmacies to make sure that that problem doesn't happen. So the entire process, soup to nuts, took 6 weeks, and we were able to answer their questions. Never did we build a data warehouse. Never did we build a report, a data mart, a cube, and we never did formal ETL. We just answered a problem using raw data. So that's essentially the process we use whenever we go out to new customers. We want to show value as quickly as possible without making these into long, risky projects with high fail rates. So let's dig into the details a little bit. So at this point, everybody asks, okay, I've heard data lakes for 2 or 3 years now. What exactly is a data lake? All a data lake is essentially is a shared folder structure that everybody has access to that contains usually a lot of data. It's arranged very smartly. So in the middle, I like to arrange things such that there's a raw folder, a laboratory folder, and an enriched folder. The raw folder is where that dirty data is coming in from whatever the external system is. And we want to get that data as fast as we can, stream it if we can, but if we have to wait every night, that's fine too. The sooner we get the data, the better. That's the point. We then have an area, again, that we give to our business users for self-service analysis. We call that the laboratory area, and it's cordoned off by username or group name. And then we have an area that we call the enriched data, and the enriched data is essentially, after we found some insight or nugget of gold in that data, we put that in the enriched area, and then everybody has access to that in the entire company. When you lay out a data lake in this fashion, it gives you a whole lot of benefits. Here's a couple of benefits. The first thing is data governance. Data governance is something that's talked about a lot. We like to do data governance very, very late in the process, and our data governance model is very simple. We essentially say that a business user or a business analyst, they have read-only access to anything in the data lake, read-only access to anything. However, write access is different. Users can only write to the laboratory area, their experimentation area. Everything else is controlled. So the enriched area and the raw area should only be written to by known processes that we can track. So this instantly brings up questions. Well, what happens if you have social security numbers or credit card numbers or personally identifiable information in your data lake? We need to, essentially put data governance around that to make sure that, people aren't reading that data when they're not supposed to. And our answer to that is really avoid putting that data in your data lake. That's the simple answer. But if you can't avoid putting that in your data lake, or you have to for one reason or another, then this becomes slightly more complicated. But generally our answer is don't put that kind of sensitive data into your data lake. Another thing you'll notice about these folder structures is they do something called a time partition file system, TPFS. So you'll notice that within a given subfolder, so on the right-hand side, we have the raw incoming data coming from our corporate timesheet system. It's organized by this time partition file system, and you'll notice that when the screenshot was taken on the right, I took that back in April, and the last day that we had in there was April 7th. If we organize data in this way, it makes queries later a lot faster, and it also makes the ability to do time series analysis, in other words, how did data change over time, much, much easier. Now, if you're worried, oh, I don't know how to create these folder structures and I wouldn't know how to query them, that seems very complicated, just know that the processes that run on top of a data lake know how to process this smartly. You don't have to. All you need to know is the basics. Where is my laboratory data? And essentially how to write into that and how to read from that. So it becomes very easy. Okay, let's go a little more detail into this and what is the actual workflow. Okay, so kind of envision this as your data lake. You have your raw folder. We have something here called a staging folder. The trusted folder is the enriched folder. Every project I work on, I change the names around a little bit just to make it complicating and complex for me. And then there's a sandbox area that we have off to the right. So here's the actual data flow. Let's say you wanted to ingest some weather data, like I had mentioned earlier, and you want to see if that correlates to sales. What you're going to do is have your IT people ingest that data, the raw weather data from your weather provider. They're going to land it the first time in the raw area, and then they're going to clean it up in the staging area. Unfortunately, weather data, just like any other data, it tends to be missing data, it's dirty data, it's duplicated data. You're going to need your IT department and your ETL developers to scrub that for you a little bit. So they're going to scrub that, put that into the staging area. Once they're confident that data is correct in the staging area and they look at it and they put all their controls on it and they think it's accurate, it's going to move into that trusted area. The trusted area is where anything goes that is properly controlled and governed data and can be distributed to end users. So that's the development process essentially for a new data feed. What it looks like in a stream model is something like this. And you're going to hear me use this term a lot. What we do is we advocate streaming data. And what streaming data means is as the data comes in, I push it through the pipeline. It never sits and waits for a batch window to open up for that processing to occur. So if we get the data every second, weather data, we can actually process it every second. If we get it every day, we're going to process it every day. It's just an unbounded stream of data. So here's what it looks like. It moves instantly from the raw area to the staging area up to the trusted area, and that's how it looks in production. Once the data's in the trusted area, now our users take over, and our users could be just our regular business analysts. They could be data scientists that work with business analysts, or they could be your ETL developers that are going to help your business analysts write their queries. And what you're going to find they do is they're going to look at data from anywhere in the data lake, the trusted area, the staging area, the raw area, and they're going to put it in their sandbox area so that they can manipulate it. And they're going to start manipulating it, and they're going to do whatever process they need to do. Maybe they need to do some additional cleaning to it. Maybe they need to do some aggregation to it. What does it look like at the hour level? What does the data look like at the day level? Doesn't matter. They're going to do whatever they need to do to answer their questions. The IT people are going to work with them. Capex people are going to work with them, and we're going to show you how to do this. Again, we have tools that we like to use, but pretty much any tool that has the ability to query a database will work fine. At some point, your business analyst or your developer is going to say, okay, we found a real nugget of gold here. We would like to take that nugget of gold and operationalize it so that we can use it in the future for reports. So that comes down to step 4. What they're going to do is turn that over to the IT team. And the IT team, the ETL developers, they're going to operationalize the workflow. And the way they're going to do that is they're going to take the data out of the sandbox area, and they're going to look at the scripts and look at the SQL statements or whatever whatever tooling you're using. They're going to look at that and they're going to translate that into the stream language. And the stream language is very easy to use. ETL developers understand it very quickly, and in fact, they can use their existing tools in most cases. So they're going to take that data out of the sandbox area and put it into the staging area. Once it's in the staging area, essentially it becomes, people are going to look at it, they're going to evaluate it, put data governance on it, and QA it, ensure that it goes through all the necessary controls and auditing, and then it's going to become productionized. And again, what productionization means is that when the data comes through the raw area, through the source systems, up through staging, up through trusted area, it's going to eventually go back down into the staging area, rerun all the scripts that were run in the sandbox area by your data scientists and your business analysts, and push right back up in the trusted area. And all of that occurs essentially almost real time. And that's the real beauty to the system. Okay. At this point, a lot of people think, well, I already have a huge investment in a data warehouse. Why would I need to have a data lake? Or what's the difference between the two? And, do I need to have both of them? Generally, the answer is you'll probably want to have both of them because, again, the data warehouse has benefits that the data lake doesn't necessarily have. But one benefit the data lake has that the data warehouse doesn't is the ability, again, for that data sandboxing. And that's the important piece that's going to give the users the ability to do self-service analytics without necessarily having, a dedicated ETL developer and IT staff to do that. There's other reasons why you should use data lakes in conjunction with data warehouses that we didn't cover, and that is I can structure data in a data lake to meet whatever the purpose is for that data. So again, I said earlier that generally data lakes tend to be slow for querying, but I can build areas of the data lake that are meant for fast ingestion of data, such as needed for dashboards or machine learning that I can't really do with a data warehouse because they tend to be loaded off hours. So again, there's plenty of reasons to have both. And we don't advocate one over the other, but we do advocate if you're starting a greenfield deployment, in other words, you don't have anything now, start with the data lake and only build the data warehouse as you need it. Okay. The last piece of this is if you've got a lot of users and a lot of business analysts and they're using your data lake and they have their own little sandbox area, it quickly becomes that data swamp. So you want to have that data catalog that essentially documents what each piece of data or what each folder in the data lake's purpose is. This is a screenshot I took of something that Azure provides, which is called Azure Data Catalog. If you're running in Azure, this is a great tool to deploy to manage your data lake, and it's only costs a few pennies a month. If you're running on-prem, you can even still use this. In other words, you can use this with your data lake that exists in your data center. It works just fine. Or you can build your own. We've built plenty for customers, so we know all about this. But essentially, this is what it looks like. The key piece to know is that you have a search bar up at the top left, so I can say, hey, I want to see all the places where I have sales data. So I can type sales in there. It's going to show me all the different tables and all the different places in the lake where I have that data. Interesting thing is once I do find a piece of data that I like, such as in the middle there, daily earthquake records, it'll tell me who I can go to for more information. So who is the expert on this earthquake data and exactly where it is within the data lake. So it's going to tell me what data lake it's in. So this is a very complex example where we had multiple data lakes, but essentially it'll tell you it's in this data lake, and then there's an explore data lake option there that essentially will open that folder structure up and allow you to start running queries. To the right-hand side, again, we have areas where you can put documentation, what the data lineage is, just any kind of crowdsourced tag-style data to actually just make sense of what's in your data lake. That's the purpose of a data catalog. Okay, at some point, this always happens, and we hope it happens near the beginning of the project. And that is the business users use the data lake and they eventually come up with that nugget of gold and they say, hey, we have a winning piece of data here. How do we operationalize this? And what I mean by that is, how do we make sure the data is accurate? How do we make sure it gets into the data warehouse? How do we make sure it gets on dashboards? How do we apply machine learning to it? All that kind of really interesting stuff. This is where business users come to the IT people, and the IT people are going to help them with the operationalization piece. So how does the operationalization piece look? That's this very last piece, and I don't think we're going to have time to go into this in a lot of detail, but I think this is where Capex brings a definite competitive advantage. We have ways of doing this that make it look like the data real time is coming in from those operational systems and it's landing into the dashboards or into the data warehouse with very, very little coding. So what we have in those little blinking lights there is essentially all the places where IT and the ETL developers take over. So again, the middle piece in blue, that's where your users are going to do their data sandboxing. But once they have that idea, then the IT staff is going to take over and they're going to put it in what we call the streaming pipeline. So the streaming pipeline essentially is how the data is going to move in more or less real time from that external data through to the data lake raw data, through all the code that and all the queries that the analyst wrote into the enriched data lake, and then shoot out the other end on the dashboard. And we have lots of tooling, and I'll show you how that works in a second. What we're trying to solve, essentially, is this chaos problem. And what we call ours is the Capex data ingestion factory. And it's a way to do ETL that's more or less real time, or as real time as you want it to be, without having to write a whole lot of complicated ETL code. So what we see at every customer we go into is something that looks like this. So if you start down at the lower left, for instance, you have a CRM system, and the CRM system has to integrate with some other line of business database. It has to integrate with a logistics database. It has to integrate with an inventory database, so forth and so on. Each of those is a custom set of ETL code. So somebody had to sit there and essentially a CRM developer had to say, I need to export the data that this logistics database wanted to see, and I need to ship that data over to them. And then on the logistics side, some database developer had to take that data, ingest it, clean it, and merge it in their existing data. This becomes chaos quickly, and this is, again, another reason, this is ETL essentially, this is another reason why these data projects have high fail rate, is this is just an unmanageable process. It's too many integration points, and it's difficult to manage. So with our stream concept, we change this a little bit, and it looks something a little bit more like this. We call this the Capex data ingestion factory. What we have is essentially a portion cordoned off of our data lake that we call the data hub or the data stream. So again, stream connotes real time. If you don't have real-time data and you only do batch processing at night, that works fine, no problem. But we like to think of it, again, as streams of data. Just the data is moving from one system to another. Here's how it works. Going back to that last slide, if the CRM system had to integrate with 5 other systems, that's essentially 5 pieces of very similar work that the CRM data developer had to do. With this model, he's only doing that data movement one time. He's taking the data a single time and publishing it out to the data hub, again, hopefully in near real time. The SAP people, they're only publishing it one time here. They're not integrating with 15 or 20 systems. Once the data is ingested into the data hub, in other words, published, now subscribers can go and listen in on the stream for events that they care about. So one thing we do with our data ingestion factory is we say everything that gets published to the data hub or the data stream instantly lands in the data lake, no questions asked. So it's less code you have to write. We do that automatically for you. Once it's in the data lake, again, then we take over and it goes through all of the processing to go through enrichment and out to dashboards and things of that nature. Or a subscriber to this data could just be the dashboard itself. So the dashboard is seeing real-time updates of the SAP system. The data hub or the data stream can also push data out to an external consumer of the data. So it could be one of your vendor partners. It doesn't matter to us, or any other data user can choose to listen in on that data stream. The real beauty of listening in on the stream, again, is as the data is changing in the source systems, when we find really interesting things, our business users find really interesting things in the data lake, we can take that data and again, look at it real time, and we can start doing things that are predictive, right? We can do machine learning algorithms and apply it right to the stream. So as the data is coming across, we're looking for events that are of interest. We're taking those events, we're putting them somewhere, or we're applying logic to them to see if we need to alert somebody. So this is essentially what the Capex data ingestion factory is. This is what your ETL developers would normally work on in the old model and what they work on in our new model. And we have ways to make this very painless for your ETL developers, and it's very easy to document. And this isn't anything that we've invented, and we haven't tried it out ourselves on customers. This is something, if you were to do a Google search, it's called Kappa architecture, and essentially this is something that the LinkedIn people invented, and people are slowly adopting this style of ETL development. So this is our Capex and data. Our Capex data ingestion factory that is kind of the magic that holds all these pieces together. Okay, so to go over what the steps of the actual data ingestion factory are, your ETL developers and IT, they're going to ingest raw data from wherever that data system is, and they're going to publish it to the stream. The stream is automatically going to take that and persist it down into the data lake. Once it's in the data lake, your users are going to be able to sit there and they're going to be able to do whatever kind of self-service analytics they want to do, data sandboxing that they want to do. Again, at some point, they're going to have the aha moment where they say, we found some nuggets of gold here, and we want to take those nuggets of gold and push that out to the data warehouse or into a dashboard or do machine learning on that. They're going to get IT involved. IT is going to operationalize it by essentially saying, I want to take this data and publish it out to the stream. Once that's published out to the stream, then other down-level systems can subscribe to that interesting stream event. Another subscriber could be that data warehouse, it could be the dashboard, it really doesn't matter. And the whole goal of this is to get less reactive with our analytics and more predictive. So again, we want to, as the end result, be able to apply machine learning to be able to predict what the next event is going to be, so that we're not dealing with old school business intelligence. We're moving into the modern era. So that's our Capex data ingestion factory. In a nutshell, it meshes well with the data lake concept. Again, all of these ideas we can do in your data center. We can do these in the cloud. Again, we prefer to do things in Azure just because most of this is just a matter of a few minutes to spin up, and we're doing analytics within the hour, where it's a little bit harder to do that in your data center. But if you do want to do it in your data center, know that we have tooling. We have lots of experience with the open source tooling that exists out there, and we can get these solutions to you quickly. We love to sit down with business users, like I said, and do all kinds of analytics with them and learn their data with them and with you, and try and show business value, essentially. So that's a little bit about becoming the IT hero for analytics. Again, we like to engage with your teams and with your business units to find those nuggets of gold in your data. We advocate that IT essentially decentralize analytics. So in the past, where it was always the data modeler sitting next to the ETL developer, and they're learning the system and putting the system together over the course of a year or 18 months, we like to do experimentation and sit with users and actually work through business problems together. It's really just the best way to do self-service analytics. The IT hero, essentially, we mentioned data governance a little bit. We definitely advocate data governance. We just think data governance should be done carefully. So if you avoid putting all of that stuff that gets all that data, if you avoid putting that into your data lake when it gets you in trouble, like social security numbers and credit card numbers, it avoids the entire problem. But we always allow our data lakes to be read-only by our business analysts so that they have access to all the data, no matter how dirty it is. We apply governance at the end to make sure that the reports that do go out the door are going against the enriched data sets that have been carefully QA'd and have gone through an approval process. Again, We feel that ETL developers and data developers in general should be sitting with business analysts. We foster that by doing that ourselves whenever we come in on an engagement. We think that IT should take any kind of nuggets of gold and operationalize it by putting the data into the stream. The stream, again, is there solely so that we can ingest more data, better data, and faster data versus having long, drawn-out ETL processes. And the whole goal of this is not just self-service analytics, but it's getting to predictive analytics. So instead of just looking at what were my sales yesterday, truly being able to predict based on today's events what my sales will be tomorrow. And that's the entire point of doing self-service analytics. So that's all I have. Mark?
Dave, thank you so much. That was fantastic. I do see that we have 3 questions in the Q&A box. If you want to, don't mind, just kind of drill into that real quick, and then I'll take us home.
Okay, sure. Can you read off the questions, Mark?
Yeah, sure. Let's see. First one is from Diane. She said, Diana, what is the best practice for sharing a data warehouse data and data model with the correct relationships to minimize the business creating incorrect relationships?
Okay, that's a really good question. So probably the easiest way to do that after the fact is to use a data catalog. So essentially the data catalog will have what all the key relationships are between the data. That's only good, of course, the data catalog is only good after all the reports have been created. If you're still in the process of doing that self-service analytics piece and you're still looking at raw data, it's highly likely that the keys have not yet been generated and put into the data catalog where everybody can look at it. In that case, the users are kind of off on their own. That's why we suggest always working with an ETL developer or a data analyst to essentially help them with that. But part of the operationalization process is exactly that. Operationalization is taking that data that the user found out of the sandbox, ensuring that it's using the appropriate keys, ensuring that there is an auditing process and a documentation process in place, because if that doesn't happen, it does become the data swamp. So again, in most cases, the data catalog will help with that key management. In the beginning of the process, when we're still doing experimentation and we don't know what all the key relationships are, again, users are a little bit off on their own. When it gets really severe and we're trying to match up keys to external systems that don't have an internal dependency, then we have other tricks we do in our data lake that does key matching, essentially. And I don't want to get into too much detail on that, but essentially, I guess the main point is you want to do as much of that in the data catalog as possible. Okay.
Great, thanks, Dave. We have another question here. Is in the initial step of data warehouse development, where you're just serving up unaggregated, uncleansed source data, how does business understand or get value from the dirty data without analytics or visualization? If just raw data, low value? No? Question mark?
No, it's actually very high value data. The dirtier the data is, the more you can read into what's going in the source system. So let me give you an example of what I mean by that. I was recently at an engagement where they had an existing process that ran at night that looked at when customer service representatives were logging into their phone station and how many hours they were putting in a given day. That process they were very comfortable with, and they were getting numbers that they anticipated, 8 hours, 7 hours, things of that nature. When we started looking at the raw data coming in from those dialers at the call center, we realized those numbers, they were very, first of all, we knew it was very dirty data, but the numbers did not match what we were getting at the end of the day. When we started looking at that, we wanted to determine, why is that? Which report, in other words, is wrong? Should we just assume the nightly report is right and it all balances out at the end of the day? Or is there really some kind of fraud going on during the day? And when you look at it, yeah, there's a possibility that some people were not playing by the rules, and we were able to capture that data by looking at the data coming in off of the dialers at the hour instead of at the end of the day. So the dirty data was absolutely invaluable, and it always is invaluable. The more you can see of that dirty data, the more you can see what's going on the source system. And that's a key problem maybe I didn't hit on enough. ETL developers are notorious for taking dirty data and they just clean it as part of their processes. So if there's some missing data in, say, a sales column, they might fill it in with 999. If they do that, we lose a lot of the semantic meaning of that data. Or let's say data comes in 1 minute and it's missing a key field, and then it comes in 2 hours later with a key field completed. Well, there might be very good reasons for that, and we'd like to know that. We don't just want to make assumptions based on what we're getting. We want to actually see the raw data. So it's not always valuable to see that dirty data, and we don't advocate that business users use dirty data primarily to do their analytics, but at some point you scratch your head and you say, I'm lost some of the data meaning, and I really want to go back and see it at its most raw state. And that's when, if you ever get to that point, where you're lucky you have it in a data lake where you can query it.
Great. And then we also have another one here from Diana. Can you import metadata from an Excel spreadsheet into Azure Data Catalog?
Yes, you can. It's actually very easy to do. Azure Data Catalog, by its nature, is a kind of manual process, which means that anytime you create a new data element, you kind of have to manually go in and update it. But again, as part of our Agile data process, we have tooling that will automatically go out there and populate a data catalog with any new data that's received. So you can take that metadata that exists in Excel and you can upload it yourself, or you can actually go out and kind of discover the metadata and have it automatically pre-populate in Data Catalog, which is the easiest way to make sure, again, you don't end up with a data swamp in a year from now. Good question.
Great. And then the next one is, what tool set do you use to fill the data lake?
Again, the short answer is we really don't care. So Azure, it has a standard set of tooling that people like to use. People that are running data lakes on premise, they may have other tooling they're comfortable with. Throughout this entire presentation, you might notice that I did not include names of technologies because the concepts are more important. So to populate a data lake, you can use Informatica, you can use SSIS, you can use Talend. Pretty much any of those tools will work. What we advocate doing is, again, using our Kappa architecture, our streaming architecture. And our streaming architecture is essentially we have tooling around that where we can look at a source system and very quickly determine its metadata and ingest that data directly without having a lot of manual intervention. So that's the easiest way to do it, is to use our tooling. Again, there's plenty of tooling out there in the marketplace that will do this as well. To be very specific to your question, the actual technology we advocate using at Capex for our process is something called Kafka. Kafka is essentially that stream component, and then we read off the stream on the other end. There's a few moving parts there, but that's the tooling we like. If you're an Azure person and you do your stuff in the cloud, essentially, we like to use Azure Stream Analytics. But again, the concepts are much more important than the actual implementation of the technology. So very good question.
Great. And then let's see here. We're running out of time, but what are some of the key Microsoft technologies for self-service BI?
Okay, so the actual self-service BI, that's a broad topic. So when I got involved in this industry, business intelligence was more what we would call today analytics. Today, business intelligence kind of connotes dashboarding and reporting, in my opinion. But I think the best tool, honestly, is Power BI. Power BI is a great tool. It's very inexpensive, and it allows you to do everything that I went through today. The entire stack can be done in Power BI. Quite easily. So what I mean by that is the actual transformation and the data learning piece. There are portions of Power BI that allow you to do that and then pass that off to an ETL developer. He clicks on a button and it shows him all the code that the analyst did just graphically. It's a beautiful tool for doing that. So that's probably the easiest way to get started with any of these projects is Power BI. Definitely start with visualizing your data and looking for the anomalies and before you go into a much more difficult tool to learn and to comprehend. Good question.
Great, thank you. And then our last question here is, if your users are not very advanced, Power BI level analysts, how do you handle JSON or XML files?
Okay, that's another really good question. The data lake abstracts most of that away for the average user. So if you have users, and we hear this all the time, honestly, is we have users that are not very advanced, they're not going to be able to write SQL, they're not going to be able to use advanced analytics. How do we get them using this? This is, again, why we like to sit with the actual business analysts. In the worst case, when you have a business analyst that really knows the business but does not know JSON or does not know SQL and really doesn't have the propensity to learn, we sit there with them and we work through the issues and we're learning the system together. They're helping us learn the business. We're helping them do all the data transformations that are necessary, and it works really well. It's a very agile process. That's at the absolute worst. Every time I start one of these projects, I hear that same refrain, and when the first day I start, I get very nervous because I think, what if this is the one project where truly the users can't do this? They're not advanced enough. And I've never had it happen yet. Usually within a week or two, business analysts, they take to this like ducks to water, and they really enjoy doing it, and they have the aptitude to do it. And again, with the modern tooling, it's really not that hard to do either.
Perfect. Thanks, Dave, and I really appreciate you going through all those questions. So, so I just want to kind of wrap this up real quick, and if you're interested, if you're ready, join our 5-day Kickstarter program. Send us an email at proposal@capexglobal.com, and then we'll reach right out to you. And you're probably asking yourself, what do you mean by that? What does that program look like? What does that 5-day starter program look like? Ultimately, it's a lot what Dave talked about today, right? Looking at identify a nagging analytics problem. We'll work side by side and apply this method that you saw today. You'll learn new ways to do data acquisition. A lot of, again, back with what Dave was talking about, we'll create a data catalog so you get to feel what that and see what that looks like. And then evaluate the different self-service tools like Power BI and such, and the data sandboxing. All that being said, in that process, you're also, we'll apply our Agile data process through that. So, with a little investment of a 5-day program, I think you'll be quite pleased to see, the results of what that program could do for your organization. And you'll be quickly on your way to being that hero for self-service business analytics within your organization. So again, on behalf of Dave and I really appreciate everybody's time today. If you have any questions or any type of follow-up, here's our emails. I'm M. Nielsen at Capex Global and Dave Wenzel at Capex Global. So again, thank you so much. Take care.
Thank you.